Okay, so all of these are a little bit different. You see, if I can take this whole argument is some angle divided by 2. So if I can rewrite it as the angle divided by 2, then I'm going to use that value for alpha. And that's the way they all look here. And you'll notice in this formula, tangent of alpha over 2 has 3 different versions that you can use. They're all equivalent, so it doesn't matter which one you choose. For me personally, I would probably choose the last one, just because it's not underneath the radical, and the denominator is going to be a single term in the end. I always like that better, but they're all the same. Just maybe more difficult to simplify. Okay, so here's an example. It asked me to find sine of 15 degrees using the half angle formula. Well, that's not an angle that we're very familiar with. But I could rewrite 15 as 30 over 2. Because 15 is just half of 30. Everyone okay with that? Now then, because it's in the form of the half angle formula, that means 30 is my alpha. So looking at the formula, I have plus or minus the square root of 1 minus cosine of alpha, which is 30 over 2. Okay, so the first thing is the answer is not both plus or minus. They put plus or minus for us to choose which one is correct. So given that the original angle here is 15 degrees, that means I should choose the positive angle, because in the first quadrant, sine is positive. So this is going to be positive square root of 1 minus, okay, what's cosine of 30? Radical 3 over 2. Do I need to draw that out? Is everyone okay? And this is all over 2. So again, this should all be underneath the radical. I've done a bad job on both my radicals. It looks like it's just the numerator. Now, your calculators are not going to simplify this. You're going to have to be able to do it without it. So, look in the numerator. In the numerator, I'm subtracting 2 terms. One of them is a fraction. So we want to make them both fractions. So 1 is the same thing as 2 over 2. Getting that common denominator. And so now that I have a common denominator, I can write it as 2 minus radical 3 all over 2. And remember, this was the numerator. So this is over. There was a 2 in the denominator. So it should be 2 over 1. And this is all underneath the radical. So now I have a fraction divided by a fraction. So I'm going to change division to multiplication, and I'm going to flip the second fraction. So that would leave me with 2 minus radical 3 over 4. And again, this was all underneath the radical. So when you have a fraction underneath the radical, you can break that radical apart. You could do the square root of the numerator over the square root of the denominator. But we know what the square root of 4 is. The square root of 4 is 2. So I can drop the square root. Everyone okay with that? Now, do I have a square root in the denominator? No, so it's rationalized. So this is radical 2 minus radical 3 all over 2. So you've got a radical inside a radical. Again, your calculators won't do that. Any questions on any part of that?
How did you go? I'm guessing it's a formula from the sine of 30 over 2 to that.
On the back of the page, that problem's on.
Oh,
That's our new half-angle formula.
I got you.
And the only reason I knew to use it is because it told me to use it. Right? In all reality, if I saw this, I would do 45 minus 30 would be my first instinct. Anything else? So we know where this formula came from. The square root, oh my thing's freezing, that's great. The square root of 1 minus cosine 30 over 2. And I just plugged in, and then it was all simplification. It's all algebra, algebraic manipulation from there. The next one, we are given tangent of alpha is 8 over 15, and we know alpha is in quadrant 3. So we want to find the exact value of the following. So I'm in quadrant 3. This is my angle alpha. Tangent is the opposite over the adjacent. I can find the missing side using the Pythagorean theorem. My guess is it's 17, but I don't know that for sure. 8 squared plus 15 squared, the square root of that is 17. So that's a 8, 15, 17. So to find sine of alpha over 2, we're going to have plus or minus the square root of 1 minus cosine of alpha over 2. So I'm going to leave the plus or minus for now because I'm a little confused. So this would be 1 minus, what is cosine of alpha? Would be negative 15 over 17. Right, I'm in the third quadrant. So there's already a minus there. So minus negative, I can write that as plus. And we said this was 15 over 17. And this is all over 2. So this would be 1 plus, nope, I'm dumb. Look in the numerator. Sorry, I had a breakthrough on the plus or minus, and so then that was distracting me. So here we go. I've got 1 plus or minus 15 over 17 in the numerator. So let's get a common denominator. So it's 17 over 17 plus 15 over 17, which is 32 over 17. And this is going to be divided by 2 over 1. You see it's the same steps. It's what we had before. Now I have a fraction divided by a fraction. Keep, change, flip. Did I just say that? I didn't. And so this would be 32 over 34, which reduces to be 16 over 17. Is everybody okay? I know I'm drawing all over the place. I'm running out of space. Is everybody with me to hear, or do I need to explain something, or we're still good? Now, same thing as before. I can break a square root across a fraction to the numerator and the denominator. So I like that because the square root of 16 is 4. What just happened? Why did that thing get so... I have no idea. Okay, the square root of 16 is 4 over, that looks awful. Then I've got radical 17. You feel like you're being taught in an elementary class now with the big, that's the way I feel, just looking at it. But this can't be my final answer, because I need to rationalize the denominator. So I've left off all my plus or minuses. So if I rationalize the denominator, this is 4 radical 17 over 17. Everybody okay with that? Multiply by radical 17 on top and bottom. Now let's choose if it should be plus or minus. So let's think through this. If I was in quadrant 1 originally, and I doubled it, right? Do you guys remember how we thought about the double angle at the beginning? So that's what I'm thinking about here. This is essentially my original. Because if I doubled half of A, I would get A, which is here. So if this angle was in quadrant 1 and I doubled it, what are the possible quadrants that the new angle could be in? If you double something from quadrant 1. Okay? It's either 1 or 2. Right? If you think, if the angle was 10 degrees and you doubled it, that would put me in quadrant 1 still. Right? But then if you think of the biggest angle you could get in quadrant 1, say it was an 89 degree angle, and you double it, that puts you at 178 degrees, which would still be in quadrant 2. So what I'm getting at here is this angle, alpha over 2, cannot be in the first quadrant. Now let's think through what could happen if it was in the second quadrant. So if it was a 89 degree angle in the second quadrant, that means I rotated 91 degrees. And if I double that, I'm at 182, which could put me in quadrant 3. Or like I said, if it was like 10 degrees here, that means I rotated 170. 170 doubled is 340, which is in quadrant 4. So starting in quadrant 2 and doubling it means it has to be in either quadrants 3 or 4. So alpha over 2 could be in quadrant 2. Right? Could it have been in quadrant 3 to start with? Okay, so if this was 10, that means I rotated 190 degrees. If I double that, it's 380 degrees, which would not be in quadrant 3. So that means alpha over 2 had to be in quadrant 2, which means here we would choose the positive, which means the next one we would choose the negative. Right? Do I need to go through the whole process on the next one? Are we okay? You guys look at the formula for cosine of alpha over 2. And compare it to sine of alpha over 2. The same principles, but the sign between them is different. So everything would be the same until here. This would be a minus. So then this would be 2 over 17. Right? But it's the same simplification process. Do I need to do it again for you guys to see that?
I did that part, but I'm confused on how you, the quadrants. Yeah, it's happened to me. I understand what you're saying with it being double, but how do you know it's not in the first quadrant?
Because I couldn't double any angle in the first quadrant and get to the third quadrant.
Oh, okay.
I took 89 degrees, which is basically as big as you can get in quadrant 1.
Yeah.
If I doubled it, I've got 178, which still doesn't get me to quadrant 3. 178 would only be in quadrant 2. So that means I know because alpha is in quadrant 3, it told me that, then alpha over 2 can't be in quadrant 1.
Yeah. So how do you decide if it's in quadrant 2, quadrant? Oh, no, I get it.
So I went to quadrant 2 and I picked basically a really big angle in quadrant 2 and a really small angle in quadrant 2. They either put me in 3 or 4. So it
Just
was
a
possible.
correction on the second block tech for today. Second block tech will go to tech after the assembly. So when the assembly's over, the tech skill students will need to come up here and load the bus at the normal location. Thank you.
It's the exact same setup. Are we okay with that? I'm still in the third quadrant. This is still alpha. This is still an 8, 15, 17 triangle. But now to do B, I have to use this formula. And so what was different from this formula to the formula we use for A? There's only one thing different. Instead of saying minus between them, it says plus between them. So this would still be plus or minus the square root of 1 plus cosine of alpha. That would be negative 15 over 17. Are we okay with that? From the triangle? I waited. Over 2. Now then, it's the same process as what I explained the time before. In the numerator, I have a fraction. So I want to get a common denominator. So that's 17 over 17 minus 15 over 17, which would simplify to be 2 over 17 in the numerator. And this is over 2 over 1. Keep change flip. 2 over 17 multiply by the reciprocal. I can cross reduce. 1 times 1 is 1 over 17. And remember, this was all underneath the square root. I just ignored that to make it easier to do the algebra. So I've got the square root of 1 over 17. We still okay? Square root of 1 is 1. The square root of 17 is radical 17. This can't be my final answer though, because it has a square root in the denominator. So I have to multiply by radical 17 on top and bottom. So this is radical 17 over 17. And again, this was all plus or minus. Now, for the same logic we figured out before, this means alpha over 2 must be in the second quadrant. Being in the second quadrant means cosine should be negative. So this should be negative radical 17 over 17. I know where you're going to get stuck the most. It's simplifying those fractions. Because since you were in, whatever, 8th grade, 9th grade, you've just been hamstrung with you simplify fractions in your calculator. And these won't simplify in your calculator. So, I mean, I know that's going to be the most difficult part. I don't know what to tell you. This was 5. So that's what I said. This was 8. 15, 17. So we've got 3 of these formulas we could choose from. I'm not going to choose this one because look at those ugly radicals. OMG, that would be a disaster. So because I can pick any of them, I would pick this one. Do I need to explain why I would pick that one? Okay. Because the denominator, first, there's no radical. There's no plus or minus. So that's good. The second reason I like it is because the denominator only has one term. If it had 2 terms, and I had to get a common denominator down here, then I may have to rationalize it as well. It just turns into a disaster having a binomial in the denominator. It's easier to have a monomial in the denominator. So that's what I would choose. Again, you can do it either way, but I think this is going to be the simplest algebra as far as simplifying it. So now this is 1 minus, what is cosine of alpha? Negative 15 over 17. So that's plus 15 over 17 over sine of alpha. Sine of alpha would be negative 8 over 17. Anything else here? So the numerator, I have a fraction. Does that look familiar? What am I going to have to do? Common denominator. So this would be 17 over 17 plus 15 over 17, which is 32 over 17 in the numerator. And so it's a fraction, and it's being divided by a fraction. So I'm going to multiply by the reciprocal, negative 17 over 8. So the 17s will cross reduce. 32 over 8 is 1 and 4. So multiplying straight across, this would be negative 4 over 1, which is negative 4, right? 4 times negative 1 gives the negative 4. So you see how this spit out negative 4 for me? And again, think about it. What quadrant did we think the angle was in? The second. And in the second quadrant, tangent, which what I just found, tangent should be negative. It'll spit that out for me. I don't have to worry about the plus or minus because there wasn't one in the formula to start with. Okay, so the first thing they want me to do is show you where these formulas come from. I doubt you care, and we're running short on time, and you're never going to do it again, so I'm going to skip it. Okay, so what's different? Like if you looked at that.
The 2 in the front of something.
Yeah. The thing that's different, this is still alpha, this is still beta, but in the end it's being doubled. So I'm just going to treat it like normal But then in the end, I know that this side has been doubled, which means this side has been doubled. And so do you know what this would look like if I undoubled it? Divide by 2, which means it's going to be over, which means the total denominator is going to be 4. Right? If this was essentially 1/4, 1/4, forget that. If this was over 4, that's 1/4. And then if I double a 4th, it's now over a half. So I'm just going to go into the problem. I should have studied this. I don't have a clue. I'm going to act like this isn't here. And then I'm going to expect to get an answer that's over 4. And then if I doubled it, it's going to be over 2. So here we go. What am I looking at? Is that what y'all says?
What do you mean? I thought, yeah. I'm just
Okay. Look at the, I'm just looking at the next page. I've got one that's already over 4 without the 2. Just ignore me. Okay, so here we go. This is alpha. This is beta. So if I plugged into the formula, I would have 1/2 times cosine of alpha, 52.5, minus beta, 97.5, minus cosine of alpha, 52.5, plus beta, 97.5, close brackets. Is everyone okay? And I just plugged in alpha and beta. Now simplify, because you have alpha minus beta in the argument. So subtract it. What's 52.5 minus 97.5? -45. Minus cosine of 52.5 plus 97.5. Okay. Hey, I like those angles. Those angles good. Cosine of -45 puts me in the 4th quadrant. All students take calculus. Cosine is positive. Cosine is the adjacent over hypotenuse, which would be radical 2 over 2. Remember I told y'all you better know those. Better know that. Give me a circle, okay? Because I can't draw it every time. Cosine of 150 puts me in the 2nd quadrant. Cosine is negative. I have a reference angle of 30. So adjacent from 30 is radical 3. Hypotenuse is 2. So that's negative radical 3 over 2. So there's already a minus there. So minus radical 3 over 2, or minus negative radical 3 over 2 becomes plus. Is everyone okay? So I'm just going to leave this 1/2 out front, because remember what's happening in the end? I'm going to double it, right? So let's just leave that half, because when I double it, it's going to go away. And inside, I already have a common denominator, so this is just radical 2 plus radical 3 all over 2. And so remember, this was doubled. So I told you at the end I was going to double my answer. But if I double a half, that's 1. And now then I've got radical 2 plus radical 3 over 2. Which means the A value must be 3. That was the question.
I was confused a little bit, but I did not know there was an
Yeah, I don't know that we are, but we'd almost have to be.
Yeah, it didn't say 5.
It doesn't. You're right.
I was so confused.
That's why I just said, well, I don't really know what I'm doing. And that's why I said I should have studied. And then I just used the formula. And then just see what's gonna happen. I'm just willy-nilly. I'm just like you guys, except I'm not afraid to plug in. It's really the only difference. Oh, I know. Scared to ask questions, scared to plug in. What about the 2 that's out front? I would just ignore it until the end, right? I think it's going to make your life easier. So this would be 1/2 cosine of alpha, which is 7 pi over 2, or that's an x, isn't it? 7x over 2 minus beta, which is 3x over 2, plus cosine, just tell me what we're going to do in the end. 7x over 2 plus 3x over 2. Oh, gosh. Write the following product of cosines as a sum. Okay? And so this would be 1/2 cosine of 4x over 2, which we can write as 2x, plus cosine of 5x. Write this 10x over 2. But now what's different? This has been doubled. So I need to double the other side, which means these cancel. Do you guys know how to find cosine of 2x? Me either. Here you go. That's it. That's all we got to do. It says, if you read the directions, it just says write the product as a sum. Well, we took something that was a product and now it's written as a sum.
How would we even have the x variable?
So, I'm going to look at the formula that has sine of alpha minus sine of beta. And I'm just going to plug in to that formula. Thank you. So this would be 2 sine of alpha. What's my alpha? 4 theta minus beta, 2 theta over 2 times cosine of alpha plus beta over 2. Are you guys going Greek? Do you love the Greek life? That's what it sounds like. Just so inspiring. So this would be 4 theta minus 2 theta, which is 2 theta over 2, which is just theta. Cosine of 4 theta plus 2 theta is 6 theta over 2. I'm done.
That's the answer?
Yep.
That's
How do you know when to stop?
Okay, here's this one. Cosine of alpha minus cosine of beta equals, are we good plugging in here?
Yeah.
Negative 2 sine of alpha, 15, plus beta, 75, over 2. All these are in degrees. Sine of alpha, 15, minus beta, 75, over 2. So this would be 15 plus 75 is 90 over 2, which is 45. So this one I'm not going to stop. You follow? And so here, sine of 15 minus 75 is negative 60 divided by 2, negative 30. So what is sine of 45? Radical 2 over 2. What is sine of negative 30? Negative 1/2. So just from my triangles, but I didn't draw them. Did I see triangles in my head? Is this like, is it the sixth sense? Is that right? I see dead people?
Yeah.
I see triangles in my finger. So then we multiply this. I can cross reduce. That's a 1. That's a 1. So I've got a negative times a positive times a negative, which is positive. And then I've got radical 2 over 2.
So this.
I just multiplied. I just multiplied.
But
This one, since they're being multiplied in the numerator, because I didn't cross cancel,
Yeah.
but since the numerator's being multiplied, because I got 2 radical 2 over 4.
That's it.
So, but since they're being multiplied there, you should make it 1 half.
Absolutely.
But earlier, because it was added.
That's correct. Multiple terms. Multiple terms mean you have to reduce every term by that.